Okay, let's do another problem just like the last. So if you wish to try to draw a sketch of this, you draw the rectangular coordinate system. Some people just are not as skilled at this, and that's okay, I get it. So vector A is only at 36 degrees, so it's in the first quadrant. It's 3,400 units long, so let's just draw it out here. That's my idea of 36 degrees right there, and I'm just kind of estimating, its length. So when I get to it, I'm going to see that its x component is right here and its y component is right here. They'll both be positive. Vector B is at 253 degrees. This is 270. So, and it's about 1.5 times as long. So here's something that's about as long. Let's go a little bit more. So here's vector B. Again, here's vector A. If I were to try to go through this parallelogram method and kind of see what I thought my answer would be, I'm looking at something like this, and the resultant will be in the fourth quadrant, I believe, from my picture. And let's go ahead now and do those calculations. So vector A's magnitude is 3,426 units in length, and its angle is at 36.37 degrees. So its x component, let's go ahead and do that, and its y component, I'm going to take 3426 times the cosine of 36.37 degrees. Once we get that number, I'm going to erase this and put that value in place. So it looks to me like that's 2,758. Now remember, that's this piece right here. It's the x component of vector A. So when you type that, hit pause if you need to right now. I'm going to erase. So that's 2,758. It must have rounded up. The y component is found by taking the 3426 times the sine of 36.37 degrees. Hit pause if you need to type that. Excuse me, that turns out to be 2,032 units. Again, that is, this line is the 2,758. And this line is the 2032. So again, here's the 2758, here's the 2032 to make up the 3426. That's at an angle. Vector B is magnitude is this, and its angle is here. So if you would take 5,607 and multiply it by the cosine of 253.07 degrees, so go ahead and type that on your calculator. Now look, vector B is in the third quadrant over here. So in the third quadrant, the x component should be a negative number here and a negative number there for the y component. So I hope you're going to get a negative value because cosine is negative in the third quadrant. So when you type that, I hope you got a negative 1632.8, I believe. And then when you type 5607 times the sine of that angle too, the 253, I'm running out of space there, put the 253.07 in right here. And I get another negative number, pretty large. I get a negative 5,364. So again, please remember that this number right here is the x component of vector B, and this 5,000 is the y component of vector B. So please just notice that when I go to find my resultant x component, this x value went to the right and this x value went to the left. So look, I had a positive x value to the right and a negative 1,600 to the left. So I add those. So take the 2758 and subtract the 1632. For whatever reason, I've got 1125, so I apologize for the rounding off. That's not quite right. I'm going to check it actually. So 2758 minus the 1632.8, 1125.2. I likely didn't use the 0.2 in my Pythagorean theorem next. Let's go here though. My y component for the first vector was this positive. It went upward. my y component for this vector b went downward, and it's much greater. This one's longer than this one. So the negative component overpowers this positive component. And when I add those up, I get a negative 3, 3, 3, 2. So would you please notice here that x is positive, y is negative. When x is positive, so here's the origin, when x is positive and y is negative, I expect my answer to be in the fourth quadrant. But nonetheless, let's first go to the Pythagorean Theorem, because what I've got here is I've got an x and a y component, and I need to find the magnitude of that resultant. So again, I don't know if I used the 0.2 when I did my calculation. So if you would use this approximate number, I've got 3517.1. Again, don't know if I used that. And then my reference angle, I always use tangent because I know x and y. And tangent, remember, is defined as y divided by x. I'm just writing that for you again to see. So if you go second tan of the y value, this 3,332, don't use the negative sign. So you can just get a reference angle divided by the x component of 1125.2. With this number being bigger than this number, it should be more than 45 degrees. I think it turns out to be 71.3 degrees. So look over here. So the resultant is, this is the 71.3 degrees. The length of this vector turned out to be 3,500. That makes sense because this was 5,600. So the length here, so the magnitude of r is 3,517 at an angle of, I'm sorry, I forgot to finish this. So in the fourth quadrant, I would take 360 minus the 71.3 degrees. So I believe that's 389.7. I'm sorry, 289.7. Or you could say at an angle of 71.3 degrees south of east, because here's east, and I'm going south of east. I'm going to skip this problem. However, I didn't mean to turn the page yet. I'm sorry. I'm going to skip this next problem. However, I would just like to tell you that this angle right here is a better angle to use than this 25 degrees. So I would take 90 minus 25 degrees and use a 65 degree angle for this one right here. To find the magnitude of this 22.3, I would just notice that this is 90, this is 180, this is 270. So see the 62? So what if I took 270 and subtracted 62.6 degrees from it? I would get 207.4 degrees. So that's what I'd use right here for this angle, 207.4 degrees. That makes sense. 180 plus about 27. And then to find the magnitude of this angle, see this 42 degrees? To get this positive angle, I'd go ahead and take 360 and subtract the 42.2 degrees. And so I would use an angle of 317.8 degrees for that one. So let's see if I can, I don't know if I can scroll enough to set up a table. I guess I'm going to go ahead and come on over here, just start to set this problem up. And so the first vector's magnitude is 41.5 degrees, and I'm going to use a 65 degree angle. The next vector's magnitude, the blue line, is 22.3, and its angle is 207.4 degrees. And then this last vector, its magnitude is 51.6, and I'm going to use an angle of 317.8 degrees. And I'm going to go find their x components. And I'm going to go ahead and find their y components. I'm just going to tell you that the x component here turns out to be 35.9, and the y component turns out to be a negative 7.4. That makes our final answer for this problem 36.7, I don't have any units, at an angle of 348.4 degrees. Go ahead and try that one on your own. It should be in the fourth quadrant because x is positive and y is negative. Again, try this one on your own, and I'm going to come back and do the next story problem.